As you'll recall, we are in our second day of the wardrobe theme for the week, which is high fashion. Thanks for joining me. Let's get started. All right, you guys, welcome back. So the other day, we tackled something called isotopes. And what we learned is that the identity of an atom doesn't really depend on how many neutrons it has or how heavy the nucleus is. Instead, the only thing that defines the identity of an atom is its number of protons. And so we're going to talk about a similar concept here, except these are called ions. But before we do that, a little bit of a review. Okay, just let's briefly remember the parts of an atom. Okay. Atoms have protons, neutrons, and electrons. In the nucleus, in the center, we have protons and neutrons. And protons, remember, have a +1 charge. They have a positive charge. Neutrons are neutral. So what that means is they have no charge at all. They have a charge of 0. And then electrons are quite small. They orbit the nucleus, but they have a -1 charge, so they are overall negatively charged. So let's, just like last week, let's start again with a thought experiment, okay? And here's our thought experiment. Here's our question, okay? What would a neutral atom look like? Okay, an atom that had no charge at all. Okay, no overall charge. What would that look like? Now, what I want you to do is I want you to imagine like a balancing scale. Okay, so I'm going to draw one here. It's perfectly balanced. Let's say that there's a bucket over here and a bucket over here. Now, here's my question. Let's say that this atom had 4 protons in it. Now, remember, protons are positively charged. Okay, so it has 4 protons in it. That means this side of the atom, or this side of the scale, we could say, has overall a +4 charge. Okay, a +4 charge. Now here's my question. How many electrons would we need to put on the other side of the scale in order to completely balance out the +4 charge on this side of the scale? And this isn't a difficult question. If you're really on top of things today, you should figure out, wait a minute, we need 4 electrons on the other side, right? If I have 4 electrons, and I'm going to make them negative because they're negatively charged, okay? If I have 4 electrons, that's going to give me a -4 charge. But guess what? When a -4 charge is met with a +4 charge, those 2 charges cancel out. So overall, this atom, if this atom has 4 protons and 4 electrons, overall it has a neutral, which means 0 charge. So hopefully this whole idea should make good sense to you. I think it's fairly intuitive. Now, what we're seeing here, what we're kind of doing on the inside of our brains here, is we're really doing this, right? We're comparing the number of protons to the number of electrons, right? And the idea here is that if we have 4 protons and 4 electrons, well, each proton and electron will cancel the other out. So those 2 cancel out. Those 2 cancel out. Those 2 cancel out. Those 2 cancel out. What do we have left over? The answer is nothing. We don't have a positive charge left over. We don't have a negative charge left over. Instead, what we have here is nothing. So that means that this atom that we just built with 4 protons and 4 electrons is completely neutral. It has a charge of 0. Okay. Now, based on this, just what we've learned so far, let's do an example problem here. Okay, so here's the example problem. Let me focus things up a little bit more here. Here's the example problem. If sodium, and sodium is Na, if sodium has 10 electrons, what is its charge? So what charge would a sodium atom have if it had 10 electrons? Okay, well, the first thing we need to do is we need to look up the atomic number. And what you'll remember from my previous lecture is that the atomic number on the periodic table will tell you the number of protons in a sodium atom. Okay, so when we do that, what do we get? Well, let me take out my periodic table here. So here it is. Here's my periodic table. You'll see that sodium has an atomic number of 11. So that means that it has 11 protons. Now, what we learned last week is that what it means to be sodium, what it means to have the identity of being a sodium atom, is that it has 11 protons. If it had 10 protons, it would be a different atom. If it had 12 protons, it would be a different atom. But 11 protons, that's sodium. So protons for sodium are 11. Okay? Now remember, protons are positive, so that means that those protons give it a positive 11 charge. A positive 11 charge. Now, the second thing we need to do is we need to figure out, okay, what's left over? We need to ask ourselves that question. Now, I'm going to draw this out, but you can probably just imagine this either in your head or mathematically. But let's imagine that we have all 11 of those protons. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are the 11 protons that sodium has. Now let's also imagine the 10 electrons that this problem says that the atom has. So let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, when we have a positive and a negative charge across from each other, they're going to cancel out. So those cancel out. All of these cancel out. But wait a minute. There is one thing left over here that has not been canceled out, and it is 1 proton. So what we're seeing here is that in this case, sodium has 1 more proton than it does electrons. It has 11 protons and 10 electrons, which means that its overall charge, the overall charge of that sodium atom is positive 1 if it has only 10 electrons. Okay, now you don't have to draw this out every time. If you can just kind of figure it out by using numbers in your head, that's totally okay. I'm just kind of pointing this out to you so that you can see what's going on. Okay, let's do another example. Okay, so let's flip back over here. Another example. Okay. Okay. If magnesium this time has 10 electrons, what is its charge? If magnesium has 10 electrons, what is its charge? Well, the first thing we need to do, like we said before, is look up its atomic number. So magnesium is number 12. It has 12 protons. So magnesium, sorry about that, magnesium, its number of protons is equal to 12. And so that's going to give it, just the protons is going to give that atom a positive 12 charge. Okay. Now, for number 2, notice something here. Okay, and I'm going to write down this logic so you can kind of see my train of thought here. Okay, what we're saying here is that there are 2 more protons than electrons. Did you guys notice where I'm getting that from, right? Magnesium has 12 protons, but in the problem, it says that magnesium has 10 electrons. So there's 2 more protons than there are electrons. So what does that mean, Mr. Queering? So that means that its charge, this atom's charge, is positive 2. is positive 2 because it has 2 more protons than electrons, and protons have a positive charge. So that'll leave it with a positive 2 charge. Now, you might be asking, Mr. Quering, is it even possible for atoms to have charges, right? Is this just theoretical, or is this something that actually happens? And the answer is that this is a real thing. Atoms do not always have a charge of 0. They don't always have an equal number of protons and electrons that balance each other out. Instead, a lot of the times atoms exist in a form that are called ions. Okay, and so this is a very important point, and this is something you'll want to write down. This is probably the biggest idea of the lecture today. And the big idea here is an ion, or ions, are atoms that have a charge. Now, why, Mr. Quering, do they have a charge? What makes them have a charge? And what we just laid out here is that they have an unequal number of protons and electrons. Okay, so because they have a charge, because protons and electrons are not equal. They either have more electrons or more protons. They don't have the same number. Okay. Now, so any atom with a charge is going to be known as an ion, but there are 2 types of ions. Okay, there are 2 types of ions, and one type of ion is what's called a cation. Okay, a cation is an ion that has a positive charge. Okay, that means that the other category is called an anion. An anion is any ion that has a negative charge. Okay, so that's the big idea. Okay, the only thing, once again, calling back to the last lecture, the only thing that defines the identity of an atom is its number of protons. Its charge doesn't matter. It can have a positive 2 charge, a negative 1 charge, a negative 3 charge. It doesn't really matter. The only thing that matters in terms of the identity of the atom is its number of protons. Okay, so let's talk a little bit about how we deal with ions in chemistry. Okay, how do we symbolize them? So I'm going to teach you how to write ionic symbols. Okay, ionic symbols. This is just the symbolism that we use when writing down ions. Okay, so here's an example. Here's the example. A fluorine atom with a negative 1 charge. Okay, if a fluorine atom had a negative 1 charge, how would we sort of abbreviate that? Okay, and the answer here is really simple. All we have to do is we have to write down the symbol for that, right? When we look up fluorine on the periodic table, okay, it's number 9, and its symbol is just a capital F. That's it. So what I'm doing is I'm writing down the symbol. And then in the top right, I'm going to write the charge. Okay, so the negative 1 is the charge. And I wrote that in the top right-hand corner. That's it. That's all I have to do in order to write an ionic symbol. Okay. Now you'll notice that I didn't put the negative over here. I didn't go negative 1. I went 1 negative. And that's just sort of a weird thing that chemists do. Okay. So you always put the charge after the number in the top right-hand corner. But otherwise, this is how it goes, right? This is the ionic symbol for fluorine. So now here's a question that I might ask you, or I might quiz you over. Okay, here it is. How many protons and electrons are there in what we just drew? So how many protons and electrons are there in fluorine with a -1 charge? Okay. Well, what we need to do first is we need to look up how many protons fluorine has. So fluorine has 9 protons because it has an atomic number of 9. So its protons is equal to 9. Now here's the question. How many electrons should we give fluorine in order to make it have a -1 charge overall? Okay? And the answer to this question is that since it has a -1 charge, that means it must have one more electron than it does protons. So here, if there's 9 protons, there must be 10 electrons. Because then, and here's kind of a way that you can check this, right? Notice if I take 9 minus 10, I get -1, which is the same as the charge on fluorine. All right, so here we go. How many protons and electrons are in O -2? So that's oxygen with a -2 charge. Okay, so the first thing we need to do is we need to find the atomic number of oxygen. Can you find it? Where is oxygen? There it is, it's number 8, and the 8 means that it has 8 protons. Okay, so the number of protons is equal to 8. Now, here's the question. How many electrons would be needed in order to give this atom a -2 charge? Okay, if it's a negative charge, that means it must have more electrons than it has protons, and so here, that means that there must be 10 electrons. 10 electrons. Okay, so, and we can check that. If we take 8 minus 10, we get -2. So overall, the charge is -2 on this atom. All right, so pretty short lecture today, pretty straightforward. Just remember, the identity of an atom only has to do with its number of protons. It doesn't matter how many neutrons there are. It doesn't matter how many electrons there are. If something has 8 protons, it's oxygen. There's no debate about it. Okay. Now, your assignment today is you guys are going to be doing another Google Forms worksheet. In this case, you're going to be kind of combining the 2 lectures and doing things all together. You're going to be using the mass number and the charge and things to find the protons, neutrons, and electrons in an atom. All right. So if you have trouble with that, remember, I'm always available by texting me through Remind, and also you can join me on either Tuesday or Thursday during our Q&A sessions. I can help you a little bit more one-on-one there as well.